Hi there. What I'd like to show in this video, which is here for my own purpose of documentation, is an Arduino board controlling an LED luminosity through a potentiometer on the breadboard, and using a Simulink model to upload the program. So the Arduino board is connected as per the diagram, which you can go back, which you'll see shortly, and which you can pause and then look at in detail. But the potentiometer is here, the LED is here, the wiring is, as you'll see shortly, looks like this. We have an Arduino board on the right and the breadboard here. Potentiometer is here, wired straightforwardly with a negative and a positive and negative going to the appropriate rails in the breadboard, positive on the left and negative on the right. The central pin goes to the analog 0 port. This is straightforwardly taking the positive 5 volts to the rail from the Arduino board and the ground. We then have a negative going to one side of the LED, and the positive goes to pin 9. Pin 9 is a PWM pin, which is like a pseudo analog port. I'm sure many can give you a better description than that, but it effectively it's pulse width modulation, I think it stands for. What it does is mimic an analog signal by pulsing the digital one. So I believe it has an input range, an output range different to the potentiometer. So what we'll do with the Simulink model, which we'll see in a second, is that we'll use the Simulink model to reduce the size or the range of the potentiometer down to a range that's closer to the range of this. So that's what we're trying to achieve. If I show you this working before we start, you'll see that I'm turning the potentiometer now, and this is glowing in brightness, and then reducing when I turn the potentiometer the other way, until you go all the way left, and it'll turn off altogether. So looking at the Simulink model, it looks like this. We have the PWM taken from the browser here under the support package for Arduino hardware, which has been installed already. We have an analog input we're taking from here and a PWM, and from elsewhere in there, which you can find by searching, we take a constant block and a divide block. All we do is we take the analog input into the divide block along with a constant. I'm using 6. You can experiment with others. We take the output and we put it through to pin 9. This is what compiles down after we've run on the target hardware here. When it's been uploaded, you'll see the model successfully downloaded to Arduino Uno displayed. So it's compiling down this program onto the Arduino board, and that's what lets us do the modeling. Straightforward. Pin 1 is the AO. I'm using a sample time of 0.1, but you can experiment with that. I don't know if it makes a great deal of difference, as long as you keep it within that sort of area. The settings for the constant are obviously just put a constant value in, and sample time is infinite. The divide block requires 2 inputs, one from the Arduino, the pin 1, and one from the constant. And so those are those settings, and the PWM board is just a straightforward pin number. only certain pins on your Arduino board give you an analog output. That's why we've selected 9 for the Arduino. It's one of these values here. The range for the PWM, as I mentioned before, is 0 to 255, and the range for the potentiometer is 0 to 1023, so 1023 thereabouts. And the idea is of the constant going into the devising into this is to reduce the value into the range that the PWM wants. And having run on the target model and checked it, everything's tickety-boo, and as you can see, turning the potentiometer knob gives us a brighter glowing, you can see it glowing brighter there, to the right, and turning to the left reduces the luminosity, as you can see there actually, and then all the way to the left turns it off altogether.